Hi everyone, welcome to my channel. This is lesson 11.6 in your algebra book, the standard deviation. In this lesson we will study what the standard deviation and the variance are. Then we will learn how to apply them on sets of values. Now, what do we mean by standard deviation? If you remember in the previous lessons when we found the range and the interquartile range, we said that they are measures of variation. We find them to see how wide the distribution of values is, or to compare between the values in a set. The standard deviation is used to compare between the values and the mean of that set of values. So we use the standard deviation to compare the values with the mean of the values. In this picture to the left, we see that the heights of the persons are almost the same. The deviation from the mean is small. So the values of their heights are close to the mean. Now what about this set here? If you compare the values of their heights with the mean, you see that they are really different. These values are spread out more than these values. So we say that the standard deviation for this set is more than the standard deviation for the set on the left. But to study the standard deviation for a large number of values, let's say for hundreds or thousands of values, we need a mathematical equation. The first thing we find to determine the standard deviation is the mean, or x bar. Now we said that the standard deviation is a comparison of the values with the mean. So we need to subtract the mean from each of the values to see the difference. X minus x bar. X is a value in the set and x bar is the mean. Usually when we find the average, we add the values and divide over their number n. But here we have a problem. In some sets we have negative and positive values. If we have negative values, they will cancel out the positive ones. So to avoid that, we find the square of each difference. Then we add these squares. This symbol is sigma. Sigma means the sum of the values over their number, and to cancel the square we use the square root. This is what we call sigma, or the standard deviation. The variance is sigma squared, or the same expression but without the square root. So it is the sum of x minus x bar all squared over n. Let's understand now how to apply that mathematically. What are the mean, variance, and standard deviation of these values? To start, we need to find the mean, or x bar. The mean of this set of values is their sum over their number. We have 5 values here, so we divide over 5, and the sum is 6.9 plus 8.7 plus 7.6 plus 4.8 plus 9. The average is equal to 7.4. Now, to simplify the calculations, we need to use a table. In the first column, we represent the values. So let's write them down. 6.9, 8.7, 7.6. Then we have 4.8 and 9. Then we write the average, or the mean of the values. This is 7.4, 7.4. If you remember, we explained before the difference between the mean and the average. We said that the average of a set of values is the arithmetic mean. So it's okay to say mean or average. Now we find the difference between these two values, x minus x bar. Then we square this number that we get here. Now x minus x bar here is 6.9 minus 7.4. This is equal to negative 0.5. 8.7 minus 7.4 is 1.3. Now 7.6 minus 7.4 is 0.2. 4.8 minus 7.4 is negative 2.6. And the last one is 1.6. Negative 0.5 squared is 0.25. This is 1.69, which is 1.3 squared. 0.2 squared is 0.04. Negative 2.6 squared is 6.76. And the last one is 2.56. Lastly, we find their sum. The sum of these values is 11.3. The variance, or sigma squared, is, if you remember, it is the sum of x minus x bar squared over n. We found this sum here, the sum of all these values. It is 11.30 over n, which is 5. And this is 2.26. Now sigma is the square root of this expression, or the square root of 2.26, which is about 1.5. Now pause the video for 5 minutes and solve Got It 1, then we will do it together. Let's start now. To find the mean, the variance, and the standard deviation, we need first to find the mean of this set. The mean, or x bar, is equal to the sum of the values 52 plus 63 plus 65 plus 77 plus 80 plus 82 over their number 6 values, about 69.8. Now we will make the table again. X, then x bar, then the difference, x minus x bar, then x minus x bar squared. X is 52, the first one, then 63, 65, 77, 80, and 82. These are 6 values. X bar is 69.8. We write it next to each of them. Now we subtract. 52 minus 69.8 is negative 17.8. 63 minus 69.8 is negative 6.8. 65 minus 69.8 is negative 4.8. This is 7.2. Here it is 10.2. And the last one is 12.2. We square each of these. Negative 17.8 squared is 316.84. 6.8 squared is 46.24. 4.8 squared is 23.04. 7.2 squared is 51.84. 10.2 squared is 104.04. And the last one is 148.84. The sum of these values is 690.84. Now to find sigma squared, or the variance, we divide this sum by 6, the number of values, 690.84 over 6, and this is equal to 115.14. Sigma is the square root of 115.14, which is 10.73. Now we see that the steps of calculating the standard deviation and the variance are not hard, but you need to focus when you have decimal numbers like this. Now, to make sure that you understood how to find the variance and the standard deviation, I want you to solve this extra question and send me the answer, or write it down in the comments. If you like to practice more, you can do question 1 in the lesson check on page 715. I will give you the final answer. The mean is 10. The variance is 19.8. And sigma, or the standard deviation, is 4.45, which is the square root of this number. Now this is a new idea. Within how many standard deviations of the mean do all of the data values fall? Of course, to start, we need to find the mean and the standard deviation to compare. Now, the mean is again the sum of all these numbers over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10. This is equal to 130 over 10, and that's 13. This is the mean. Again, we make a table to find the standard deviation. Here we don't really care about the variance, we just care about the standard deviation, because the question here is about the standard deviation. Again, we make a table. If you have repeated values, you write them again. When you find the standard deviation, sigma, it has 2.76. Now, to solve this question, we need to order these numbers on the number line. The smallest value is 9 and the greatest is 17. So let's start at 8, 9, then 10, 11, 12, and 18. I like to represent at least one value less and one value more. Okay, now let's represent our data. We have 12, it's here, then 17, then 15, then we have 13, it's here, then 9, it is right over here, then 10, 12 again, then we have 10 again, then 15, and 17. To check, you can count the values. Here you have 6, 7, 8, 9, 10. These are 10 values, which is the number of values you have. Now the mean is 13. Now we go one standard deviation to the right. 13 plus 2.76 is almost here. And 13 minus 2.76 is almost here. Somewhere between 10 and 11. Is this enough to cover all the values? Of course not. We need another standard deviation interval to cover these values. I mean, 13 plus 2.75 is less than the greatest value you have, and 13 minus 2.75 is greater than the least value you have. So we need two standard deviations to cover all the values. Within how many standard deviations of the mean do all values fall? They fall within two standard deviations. Actually, this is all for this lesson. We're not going to study the other problems in the book. This is enough for me. I want you to solve this homework by the end of the day and send it to me on Class Dojo or to my email. If you have any questions, feel free to contact me. Thanks for watching.